I'm Stephanie Schwartz. I am a professor at Millersville, so hi to any alum that I can't quite see. My experience with AI is long. I've been in AI research since the early 90s, so 30 plus years. So to me, the development of large language models actually came as a big surprise. I think it surprised a lot of us in industry and even in AI research, sort of the performance and the rapid availability of the tools. So some of what, as a CS educator, I've been thinking about is how are jobs changing as we're in software development, and how should that, or should it at all, impact how we educate software developers? So that's going to be our focus today. I will say that my AI experience is long, but my experience with generative AI is minimal. I haven't used it a ton for coding. I've used it for a lot of other tasks. But when I'm coding something, I really need to understand it from soup to nuts, so to say, because I need to understand where students are going to struggle in things, so I don't use any assistance when I'm coding. We each bring a different perspective to this. I have a lot of experience with CS education, minimal experience with generative AI. I'll turn it over to, and I should say we are all related in case anyone is wondering about that. This is my husband, Ed, my son, Nick. So.
All right. Hi, I'm Ed. Like Stephanie, my background is in computer science. I'm a senior research scientist at Carnegie Mellon Software Engineering Institute. So I study reverse engineering, decompilation, lots of fun stuff at the executable and binary level. I've been using generative AI for a few years now, both to help me when I'm coding prototypes, and also on the research side, looking at how we can train models specifically to help reverse engineers learn things about code from the executable level. Nick?
So my name is Nick Elzer. I am the lead engineer over at Cube. We've presented here for the past couple years now. I have minimal coding experience, but I do use generative AI a lot to integrate my hardware, just make sure I have my wiring right, that we're kind of using the right hardware to get where we need to go. The gist of where I use it the most is really just testing my hardware. It's fairly good at the high-level things, simple scripts like that, but as soon as we start getting into the low level of how we're using it on our satellites over at Cube, there are inconsistencies, and you can only really get good results with as well as you can communicate your idea to it. And I, again, don't have too much software experience, so I can only really talk with it on a high level and have to rely on my software engineers a lot to actually get final products or anything along those lines.
Okay, so that's kind of why we thought it would be a good mix of backgrounds and experience between being educated as computer scientists, being educated as engineers, and using the tools, not using the tools, et cetera. Because our focus today is a question that I've had, which is, okay, now we have these tools, people are using these tools as software developers, how should that change how we teach computer science, or should it? And so that'll be kind of we'll keep coming back to the education question. So, and it's been billed as a panel, and I'm sorry to disappoint you, but it's half kind of we'll talk about these things, and half we want you to give your opinions. So less panel and more discussion in the last half. So prepare yourselves. If you're having thoughts, formulate them into things you want to speak into a mic and tell other people about. So the first thing we're going to present, and Ed will do this part, kind of how large language models work. because we think it's important to understand that, to kind of understand some of their strengths and weaknesses. And then Nick is going to give a live code demo. I know, it's terrifying. But what's been interesting to me is how well he can use these generative AI tools without really knowing how to code. And I think for a lot of us who have been trained in coding, it's hard for us to imagine that. So I think that'll be really interesting for us to kind of see from that level, to understand how these tools can be used without that kind of in-depth education. And then many of you filled out surveys, which I really appreciate, to talk about how you're using generative AI. So I'll kind of give a snapshot of how the CPOS community is using it, what tasks, how happy they are with it, how organizations are using it, et cetera, and then we'll launch into discussion. So.
All right. With that, I'm going to start talking about what are large language models. So this talk is titled AI or generative AI in education, but we're software developers, and so the AI that we're most likely to use are textual AI. So that's why I'm going to be talking about large language models rather than like image generators or music generators or something like that. So let's start with a language model. What is a language model? Very simply, it's something that tells us how likely it is that a given phrase, or how often a given phrase, is part of a certain language. Okay, that's really good. So if we have a phrase, CPOSC is a wonderful conference in Lancaster, Pennsylvania. Yeah, that's a pretty reasonable phrase, pretty likely. Okay, CPOSC is a jumping for bananas and monkeys. That's a little bit weird, probably not so much part of the English language, but maybe it could be like a band name or something, so we'll say maybe. This was just me, hitting keys randomly on my keyboard. This is not part of the English language. This is a bunch of emojis. Maybe not part of the English language, Maybe nowadays it is kind of part of the English language. We do use this in our communication, so that one's a little bit up in the air. But the whole point is the language model is telling us, which of these is English, which of these is not, and, which one is the most common. So I guarantee you have seen language models before, all right? If you've ever used any kind of software that has an auto-completion feature, you've used a language model. All right, so let's say I have the phrase, I'm going to the store to buy blank, right? Probably immediately in your head, you're able to come up with some reasonable items that we might fill in the blank for, right? This is, again, yet another example of something that a language model can tell us. Similarly, if we have a word that is just absolutely ridiculous and makes no sense there in that blank, the language model will tell us that. So, all right, you're all experts in language models now. Congratulations. Why do we care about these language models? Well, one of the things that we can do if we have a language model is we can use them to generate text. So this is actually going to be a video from my phone, and this is Microsoft Keyboard or something like that. And what I did is I just started hitting the predictions or the suggested text in the middle and just started hitting it randomly, more or less. So those predictions or those suggestions are coming from a language model, and you can see that just by taking whichever ones the language model says is the most likely at that point, I get something that looks kind of reasonable. It doesn't make a whole lot of sense, but I think we can all agree that it's English, right? So hopefully this is starting to get you thinking of how all this language model stuff actually connects to AI. Kind of under the hood, this is how it's actually coming up with its responses to you. It's deciding, well, the next word is this, the next word is this, and it's iterating that over and over and over again. So to kind of recap all of that, a language model, if we just look at what it does and not how it works, right? We basically have a blank in a phrase. We ask the language model, how do we fill in the blank? And the model gives us some suggestions. And it'll also tell us, basically rank them and tell us how likely each suggestion is. So that's what these models do. How do they work? How do we build one? So there's basically two kinds of ways for building these models. So this is the older one. It's the statistical way of building a language model. And one way that you can do this is using n-grams, which are basically just a sequence of words. So here are n-grams with n equals 2, or bigrams, and you can see each one of these highlighted pairs is basically telling us something about the English language, right? Basically that, the is a word that might appear before quick, that quick might appear before the word brown, and so on. And so if we go through lots and lots of language, and we basically record these bigrams, we get this statistical information about what the English language looks like. So this is a table. This is not from the English language in general. This is from something to do with restaurants. I don't know exactly. But you can see some of the most frequent bigrams that appeared in this language are I want to eat Chinese food. Okay, so you can get a good feeling about what that particular book or whatever it was actually about. So imagine doing that for all of the language that you can get your hands on. And that's how we would have a statistical language model. Now, most of the AI that has happened recently, the big advances that we're all super excited about, a lot of it has to do with neural networks. So that's the other type of language model that is common. But to talk about neural networks, we have to talk about the building block of neural networks, which are neurons. So neural networks basically consist of millions and billions of these neurons. Neurons are at a high level. They're basically a simple function or a computation. So there's some inputs to the neuron, and these are going to be numbers that sort of correspond to words. We're not going to worry about the details of that too much. And because it's a computation, we can just write out, what it means mathematically. All right. So we have these inputs. For every input, we have a weight that is paired up with that specific input. And we're going to multiply the inputs with the weights. Now, these weights are important because they are the part of the neural network that's actually learned. So when you think about, where is kind of all the details about the English language? So in the statistical model, right, that's in the bigrams that you record. In a neural network, it's all going into these weights. Okay, so that's where kind of the real information is stored. So we get these weights, we multiply by the inputs, we add them all up, we run through some function that we're not going to talk about, and the output of that function is the output of the neuron. Okay, so in kind of a nutshell, that's how these things work. If you only remember one thing, remember that the weights are really important. All right, so we have our neurons, we're going to put them together, meaning that we're going to take the outputs of some neurons, we're going to connect those to the inputs of other neurons, and we're going to do that a whole bunch, right? And that's going to give us a network. And you can kind of see here that we have different layers inside of the network, and there's like a whole science to building these things, and it's pretty complicated. We're not going to worry about that. The important thing that we need to know is that there's a ton of these. So GPT-4, for example, has almost 2 billion weights, which corresponds to the little arrows in this diagram. So just try to imagine how massive that particular model is. That's why these things can capture so many subtleties of language compared to something like a statistical model. I mentioned that these models are trained. So typically, large language models are pre-trained on large amounts of general language. So think of the fill-in-the-blank kinds of examples I had earlier. This will often come from books, different pieces of the internet, etc. And we'll talk a little bit about why that can be important in a minute. And then typically these models are fine-tuned for some particular task. So for ChatGPT, for instance, and models like that, they're going to be fine-tuned to basically understand, here's some reasonable examples of what a conversation looks like. Because if you're just teaching it language, it might not be able to know exactly what you want. All right, so that is how LLMs work. I'm just going to talk a little bit about strengths and weaknesses, and hopefully we'll get into this a little bit later in the discussion and hear kind of what you guys have experienced as being the largest strengths and weaknesses. But here are just some to kind of get your thoughts started on that. One strength is that they are very fast. They can solve certain types of tasks way faster than a human possibly could. These new models are kind of exciting because they're creative. They can actually generate new content that they didn't see during training. They don't always do that. Sometimes they do regurgitate content, but they can generate new content. Oops. They are really versatile. So they have knowledge about a wide variety of topics. You can often, in many cases, teach them how to solve new tasks by giving them just a couple of examples and then asking them to perform some problem in that new task. But of course, there's a lot of downsides as well. Safety is a concern. If we ask a large language model, how do I make a bomb? Is that something that it should be able to answer or not? That's kind of a big question, and that's a big concern that, we might be making too much information too readily available. They're really computationally expensive. So there's a reason that these most recent models generally don't run on the computers in your house. They're just enormous. And so it costs a lot of money both to train them and to be able to query them. And I think the biggest one, in my opinion anyway, is that they're not always accurate. In fact, many times they're very confidently incorrect. So I was actually chatting with ChatGPT about a month ago, and it told me that Edward J. Schwartz wrote something in a paper. I did not write that paper, and I did not write the thing that it told me I had written. So the worst thing about this is that often a lot of the things that it gets wrong actually sound really plausible, unless you know kind of in-depth information about that topic. And finally, as with many AI systems, these systems learn from their training data. So they might pick up on bias or inaccurate information that's coming from that training data. So, if you're training from an encyclopedia, that's probably pretty safe, you would think. But if we're training from the comments section on YouTube, now things start to get a little bit spicy. All right, so that is it for my discussion of language models. I'm now going to hand things over to Nick, who's going to show a live demo, and hopefully we've appeased the live demo gods enough today. And while he's getting that set up, he's going to give a live demo showing basically how to work with ChatGPT to add code to his hardware project.
All right, so as we have established, I don't have an education in coding or computer science or anything along those lines. What I do know is how to do some basic research and to be able to get at least to a GitHub page that has drivers or libraries for the hardware that I'm going to use. Move this over here a little bit. So I found, first I'll explain my setup. I'm using a Raspberry Pi Pico with a IMU sensor that I got from SparkFun. So I did a little bit of research. I want to use MicroPython as our language here, and I came across this library, and I looked at this and can get fairly overwhelmed fairly quickly because I don't know anything of what's going on. So what I can do is copy this file, give it right over to ChatGPT here, and kind of give it a little explanation of what I'm trying to do, trying to test out my hardware. I have 4 LEDs here set up so that hopefully when I tilt the IMU to the left, it'll light up a red LED. When I tilt it to the right, it'll light up a green LED. A fairly simple script just to make sure I know where the axes are on this IMU module and prove that I have my wiring diagram correct. So, it's fine. I'm just gonna kneel. So first, I'll give it a little explanation. I'll say, good afternoon.
It's important to be polite.
Yeah, I've experienced when I'm nice to it, it's nice to me back. So
I didn't teach him to code, but I taught him manners.
it's true. So good afternoon. I am using a Raspberry Pi Pico and a SparkFun ICM 20948 IMU, and I am hoping, as I can type, I'm hoping to demonstrate a simple script where when I tilt the IMU to the left, it lights up a red LED, and when I tilt it to the right, it lights up a green LED. The red LED is on pin 14, and the green LED is on pin 15. I found this library/driver on GitHub, but am unsure of how to implement it. Could you please write, oh my goodness, write a basic script to demonstrate this? Here is the driver. And we'll see what it kicks out here. So first, it's kind of giving me the basic setup here for the code. It's going to initialize the sensor, sets up the GPIO pins, and will read the acceleration along the x-axis to determine the tilt direction. Based on the reading, it will light up the LEDs. So as you can see here, it's automatically using I2C as the communication protocol along the Pico on the pins that, well, actually, I forgot to tell it which pins I set it up on. So I can tell it a quick fix. I actually set up the IMU on pins 0 and 1. Can you please apply this fix? Certainly. See, it's very nice when you're nice to it. And it'll go through here, and it'll rewrite this and fix the pins like instructed. And it implemented the pins on the LEDs like I originally told it. And it gives some nice comments here to explain how the code is working, which is nice because then I can have some explanations along and understand it a little bit better. So now I'll go over here to VS Code. I'll make a new script. And I'm using a extension in VS Code called MicroPico, which gives you a nice little bar at the bottom to integrate and see what's going on with the Pico, so you can see my Pico's connected. And now I'll give it a quick run. And first I have to save it, so we'll say live demo 1.py. So we'll give it a run here. And hopefully you guys can see this. When I tilt it to the left and to the right, it's doing it pretty right. But there's something weird going on with the blue LED, which it shouldn't be writing anything to that. So we'll say stop. But first, what I want to do is go over here, and we're going to add a second implementation. So I want to see the red or the blue and the yellow LEDs come on when I move it forward and backwards. So we'll say, I would like to add some functionality to this, where when I tilt the IMU forward, it lights up a blue LED on pin 16, and when I tilt it backwards, it lights up a yellow LED on pin 17. Can you please implement these changes and provide the full script? Now, I have tested this demo before, and it will be very literal in what it comes out with. Like I said at the beginning, its outputs are only gonna be as good as your communication is to it. So it is essentially a robot, and it will do exactly like you tell it to. The data coming through will probably be pretty messy because there's no filtering or anything going on because I didn't tell it to add that in. So when I move this around, these lights should be flickering back and forth and everything because I'm just going to be tilting it by my hands. It's not going to be perfect along an axis. So how's it going to decide which axis to light up? So go over here, make a new script, just copy and paste it in. Live demo 2. It's always harder to type when you're typing in front of a bunch of people. And we'll give it a run. Now, these lights are going all over the place because it's not exact with its filtering. So it's not perfect unless I tell it exactly what I need. So it can't see what just happened, so I'll give it a little explanation. The lights were lighting up very inconsistently because I am human and cannot control the exact axis very well. And I do have a decent understanding of how this sensor works, so I can give it a little bit of a hint of the direction I would like it to go. So I'll say, can we look at the magnitude of the tilt so that these lights are more stable among the axis that I am tilting it the most. And we'll see what it kicks out here. And it gives a good little explanation here about what it's going to do to change the script. So it's going to calculate the magnitude of the tilt for both the x and the y-axis, compare the magnitudes and decide which one is predominantly tilted, and then based on that, it'll light up the corresponding LED. And thanks to the comments that's putting in, I can see exactly where it's doing this. So calculate the magnitude is right here, and it's just doing an absolute value of these. And then there's some extra logic in here to determine which axis is being tilted the most to light up. And this should clean it up a bit. Give it a new file, paste that in, save it as live demo3.py. Now hopefully we should see that these lights will be a little bit cleaner. So left and right, it's still jumping around a little bit, but it's definitely better than it was before. And now forward and back, we got the yellow and the blue. So now, with this code that I have, I can determine which axis is the X and Y, and which is the positive and negative directions of these axes. And this is essentially the most that I would really use GPT to demonstrate or to use its code output for, because I don't know enough about the code to get more in depth for lower level stuff. But I proved that my wiring is right, it's on the right pins, I know the axes of the accelerometer so that when I'm implementing it in a project, I know where I want to position it and which axes to use for different things. So I can go farther along in the hardware development process without having to interrupt any software engineers for doing their main tasks with some of this silly stuff. So it saves time, it's a bit more efficient, and I just banged out that whole project in, I don't know, a couple minutes. So that's the live demo that luckily didn't blow up in my face.
All right, so was anyone surprised by the demo? Is anyone kind of like, oh, I did not know that you could generate something that worked that well that quickly? Because honestly, I was when I was first seeing this, and I was like, I know he doesn't know how to code. So I'm kind of freaked out, which led to somewhat of an existential crisis. Because I teach people how to code, and maybe they don't need to know how to code anymore. And so I started thinking about this, and I also really felt kind of betrayed, right? I've spent 30 years in AI, and now AI is like turning on me. So I started thinking about this, and a lot of it is kind of interesting to me because when I started out in AI 30 years ago, 30 plus years ago, sorry. As Court said one day, we're not arguing with you, you're old, it's fine. So we initially in AI really came to the problems thinking that we needed to deeply understand how human beings do these things so that we can then develop computer models to do them cooperatively with us, et cetera. So I was studying language, and we were really of the impression that, okay, we need to be linguists and computer scientists, and we need to understand how humans are generating language, how the thoughts work, how that comes actuated into words and sentences, et cetera. And we need to understand how we take in language and what kind of model we have and all of these things. And it just seemed impossible, right? So I started out on a PhD with this kind of idea that I had to deeply understand all of this, and rapidly became disheartened and thought, you know, what I'm doing right now is never going to work. It's never going to be used. And I went into industry and developed some software for a while. It was easier. I came back to finish my PhD about a decade later, and everything had changed. Now we were doing all kinds of statistical things. We're not trying to understand the process. We're not trying to understand how people make decisions or use language. We're just throwing numbers at it. And it was actually working. And I was like, oh, this is weird. But okay, I can see this maybe. And then over the next, 10 or more years, memory capacities and data, availability just ballooned. And we were able to do deep learning and have much more data and much more memory. And then all of a sudden, I watched, the tech news, and I was like, what are these large language models now? So I want to kind of bring that perspective to this. Like, we are used to being a disruptive industry, and we have just disrupted ourselves. Because now we've developed tools that are doing things that we're good at. So I wanted to kind of share my existential crisis and see how they're being used, what people think, and how should this change how we teach future software developers, or should it not? So we sent out a survey, and I'd like to thank Elise for helping me with the survey very much. So I'm just going to present the results from this kind of in a story fashion. And then we'll talk about some of our perspectives and try to, come to grips with this a little bit as a group. So respondents, we had 42 responses, which really, that made me happy. It just seemed like a really good number. And then as I was putting together the slides, the 43rd person responded. And then I was like, no. I turned off responses at that point. They're back on now if you want to. But we're mostly developers with some sysadmin DevOps, technical manager and leadership, some students, which is great, and then kind of a little bit of a mix of retired or software, others, people that filled in other. So mostly technical folks. And most of us are using generative AI in some way, all right? So 69 to 31. So we have a lot of experience in the community at this point. Those who haven't used generative AI are a mix of wary and interested but haven't gotten around to it, okay, is how I interpret this. So there's a lot of, I don't trust it because it makes too many mistakes, I don't really see the value, and one who I respect who says, I generally find it disingenuous and unlikable. You might have been being mean to it, I'm not sure, but yeah, okay? Yeah. Nice begets nice. No, I have to double check work, which is very fair and something that we'll talk about more. I can read down there or up there. But most people were like, I just haven't gotten around to it, but I'm interested. Okay? Yeah, Ed has a clicker. Okay. Oops. So how are we using it? And Elise and I really brainstormed to try to come up with tasks to see what we thought people were using it for, and it turned out pretty well, I think. The largest tasks we saw were starting boilerplate code, looking up commands and syntax, so okay, using it basically like I would use Google, right? And coding specific low-level tasks, explaining existing code. And there were some comments in the survey that said, like, don't want to throw my fellow developers under the bus, but half the time nothing's commented, so I throw it in ChatGPT to see what the heck it's doing rather than me reading through it. So that made a lot of sense. People are mostly not using it for large tasks or systems, kind of beginning to end. A little bit of use in finding security vulnerabilities, which I found interesting, hadn't really thought about that. Explaining existing code, debugging existing code. So pretty wide usage. Most of us are very happy with how it's doing. No one hates it. When do you see something where no one hates it? And 16, almost 17% love it, okay? So pretty high level of satisfaction. Overall, as a group, we think that it's going to have a big impact on the software development industry, if it hasn't already. So huge, definitely beating out minimal there, large skew. And we're using it in various places. We're using it, thought I had another slide over there. We're using it at home and at work. So here we have mostly yeses, all right? Either using it in both technical and non-technical tasks, or one or the other. So the vast majority of organizations are using it in some capacity. But, and this is where I thought things were interesting, we don't really feel as sure about how much it should change education of software developers, all right? That skew towards we love it, it's gonna have a huge impact on software development was very, very strong. This is more sitting in the middle, with a lean towards it should have impact, but nothing like we saw before. And this was a really interesting question. So based on your experience, which of these statements do you most strongly agree with? So the blue is basically, look, do it the way it's always been done. Don't mess with it. They learn the way they learn, all right? And that's a pretty big share. The red is, yeah, they can use it for basic stuff, but they should learn how to write harder stuff themselves. And this is the majority response. And I have to say, as an educator, I have no idea how to do that. How do I teach them to use generative AI for the easy stuff without doing the easy stuff and then be able to do harder stuff? So I want to talk about that a little because I think there's value there. I just am not entirely sure how we go about that. For the yellow, it's, hey, they should be able to learn and write and debug their code, but they can use AI for stuff like documentation, right? But not for generating the code. And then the green is more, hey, teach them to use generative AI, even if they learn less about code from scratch. Definite minority there. So that is kind of where we stand as a group, which I found heartening in some ways, because we're still saying, I think, that the education that we got is valuable and is helping us, even though these tools are now available, that we still need that. And maybe that's because of the skill that is required to use AI and leverage it well. So we asked this question, what do you think are the most important skills when coding with generative AI? So understanding the boundaries of what it can and cannot do got a decent share. Understanding the code that is produced got a very large share. Being able to debug, adapt, or improve the provided code yourself, and thoroughly understanding the task you're trying to accomplish. Now, I think what was interesting watching Nick do the demo is that he very much understood the task he was trying to accomplish. Like, you can't come in with vague ideas and not really know what you're trying to solve. That's not going to work very well. And also that generative AI can help him understand the code that's generated. So that's kind of an interesting piece. Okay, so now that's it for us. Now we want to open it up to kind of a group discussion about your experiences, your thoughts about if you were going back to school for computer science, at this point, how would you want that experience to be different? So, yeah, all right. So most people seem to feel that future software developers still need to understand how to code from scratch. So why? Or why not? Either is welcome. So what do you think? Is it important to understand how to do it from scratch? Do you still need to know how to write a for loop? We've got our mic runners because nobody wants to see me well, maybe some people want to, some alum might want to see me jump off the stage, but Ed definitely doesn't because he knows I'll be in crutches.
I do, though.
Just for clarification's sake, are you in this, or are you thinking, do you have like specific syntax in mind, or just conceptually?
I'm kind of at the conceptual level right now, trying to reason through it.
Because I would agree, I think that people should have to, or be able to understand conceptually, but I think one of the great things about AI is if I am working in a language that I don't know so well, I can sit down, write the whole thing in a language I know, and then just copy, paste, and say, like, make this Java, and it'll just do it. But I have the foundational theory of, like, I know flow-wise what I want to do, I just don't have the syntax off the tip of my tongue.
Right, and translation is definitely an interesting way to go about that. I know how to do it in this language.
Yeah. So I think a lot of, like, in college, like, my Intro to CS course was focused on Python. I didn't get it then, I don't get it now, it breaks my brain, I hate it, I'm sorry. I'm sorry. I want braces. And so being able to maybe take the syntax out of an intro course and just, even something, there's tools like Scratch now, being able to say you don't need to know where the brackets go, where the colons go, but do you understand why you're getting this result here? And from there, I think once you have that, go nuts with, AI here, there, otherwise you know what's happening.
But learn to program in something is what I'm hearing.
Yeah.
Who else? Oh, Joel behind you, too.
So from my perspective, understanding that I don't have a full traditional education when it comes to computer science, I went for information science, took some computer science, and I am otherwise an autodidact. One thing as somebody who's in this profession, I want to see new people coming in, is to understand that you have to question all of the responses because it's learned from what we said. And I know how to program every day in 4 languages, but I have experience with 20. I don't work with all of them every day, so yes, translation is a particular key. But what I know from my expertise is, a lot of times when I look at what the model has produced, it's accurate enough, but that'll get you an intermediate job, maybe a junior job without an issue, but to be senior or higher, you have to have been taught not a language, but the practicalities of metaprogramming, the way the algorithms work, so that when you do get this code, you have the ability to absorb and understand, not just by what it says it does, but by actually reading in whatever language what it actually does do. And
Yeah.
that's the challenge that I see in this mix, is how do you give them that education without giving them some of the traditional thorough and in-depth education of how it works from not a particular syntax flavor,
Right.
but from the actual implementation patterns of how real science this works.
Yeah, so algorithmic knowledge, computational thinking, being able to work through what's going, kind of that troubleshooting as well, right? It's not doing what I expect in these cases and logically thinking through that. Ed, do you have anything to say on your experiences on sort of?
I certainly agree that I tend to program in a bunch of different languages and do it seldom enough that I am just horrible at syntax. I don't know that. Probably in almost any programming language I would sit down to program in, I wouldn't be able to do it without opening a manual or something. So I think there's definitely something to be said about not being as dependent on knowing all the details of syntax. I certainly agree with the notion that you do need to have some fundamentals to understand what's going on. So at least in my experience, as you try to use these models to work with or generate programs that get more and more complicated, they introduce more and more errors. And so if you don't know how to read the program and debug it, you often run into problems. So you can, Nick kind of showed an example where he saw some behavior he didn't like and he told the model about it. And that works, in my experience, up to a certain point. But once a program gets to a certain size, in my experience, it won't be able to figure out what went wrong and fix it.
Nick, have you experienced that tipping point, or?
Yeah, I definitely have. There have been times when Cube was expanding and we didn't have a dedicated software engineer, so I was trying to take on a lot more of the software engineering at hand. I did have some basic fundamentals. I took a mobile robotics class at Millersville University and had to create an autonomous mobile robot that navigated a maze, and there were a bunch of constraints and stuff on that, where I didn't use AI to help me write that code. I did have a partner that was a CS major, and learning those fundamentals have really helped me with the algorithmic side of things and kind of where things may be breaking down and kind of how to structure different programs. But when I was undertaking a lot more of the in-depth software engineering side of things at Cube, there were definitely times where I didn't understand enough to really crack down on where in the code this bug is happening. And it was such a large script that at the time I only had GPT 3.5, so there were text limits and stuff like that. And giving it bits and pieces or trying to find the needle in the haystack in that sense, it can be overwhelming even for the AI, where there may be several issues and the cascading effect throughout the script, it doesn't necessarily know where it's breaking down, and it may try to fix your code, but it ends up breaking it even more. And I've definitely sat there for like hours on end just sending stuff into GPT saying, now I'm getting this error, what's happening? Now I'm getting this error, what's happening? And the tides definitely turned as soon as we started getting software engineers in there where, you know, we could sit down together and talk through what we think is happening, and they had much more fundamental knowledge on what's going on. And as I've learned through my software engineers and not just AI, I've definitely learned more in that aspect rather than just trying to feed things into GPT until I get something right, or doing my own research on, you know, Stack Exchange and that type of stuff. So
it feels like we kind of agree that we need to bring knowledge to the process in order to be the most successful. Do you think that... Oh, I'm sorry. Go ahead.
Okay. Stephanie, I guess you mentioned that you teach people how to code, right? But I mean, as far as what I know, computer science major was not just about how to code.
Right.
That's a lot of other fundamentals.
Yeah. Oh, yes.
Right. And so, I mean, do you mind I turn this question around a little bit? Say, for instance, do you know the current, not the future, but the current software developers still need to understand how to write code in assembly language? Maybe not every single one of them, I guess.
Maybe
right?
not everyone. Ed would say yes, too.
So which means, I mean, I guess in education, so you see, code is just a kind of tool, and tools change. We used to have C, C++, but nowadays we have Python, which is easier to get into. But I guess some fundamentals would not change that often. Like, we still learn calculus, which was invented hundreds of years ago nowadays. So what's your take? I mean, if you're going to redesign the curriculum of computer science, how would you single out the most fundamental piece of the curriculum?
Yeah, and I entered into this really not knowing that answer. So this is a process, and you know, this is my expert pool to kind of, because I'm not using it as a software developer, so I'm not seeing quite how it changes the job and you know what you need. So to me, I think it was kind of a relief to see we still need the thinking and the algorithmic, you know, this is how I kind of put down my thoughts in an order that can be codified. So yes, our tools have changed. In the beginning, we had to write directly in assembly, and before that, even machine code. And assembly was a relief to many. And yes, then we got C and C++ and Python. But those are all, okay, I'd say machine code to assembly to high level. Those are steps. But they're certainly not something generating that for us, right? You still had to go through the thought process at whatever level. And as those tools became higher and higher level, the problems became so much more complex. We were not trying to write giant software systems in assembly. Like, we were trying to write small tasks to automate jobs and make them more efficient. So my question coming into this is this more of a fundamental shift? You know, and so far I don't think it is from everything that I'm hearing in terms of feedback, but I wasn't sure. You know, because now we have something that is spitting out the code, and that hasn't really been the case in other iterations. So I don't know if that, my take is, I think that the thinking is still very important, the process is still very important. I'm trying to figure out how to incorporate the tools. So at this point, I'm not seeing a fundamental shift in curriculum, like from my perspective, but I still want to do a lot more research. But I do think, well, let me ask you. Do you think that students should be taught how to use these tools in the process? And if so, at what point? And how do we convince them that they actually need to learn to code in the beginning before they start using them? That's kind of some of the pieces.
Yeah. Personally, I don't think they need to be taught, because it's just like we don't need to be taught how to use a TV set in the modern society, right? I mean, the environment would teach them almost automatically. I mean, I guess
You'd be somewhat
education.
surprised at some of the things students don't realize as they go through, like that you would think they'd pick up from the environment.
Well, you know,
Like debuggers, for example.
yeah.
People, if they're not taught to use a debugger, they will brain hammer that code forever. So I don't know that I totally buy into that assumption. Or they may use them poorly. Like, should it be incorporated in a positive, constructive way in the curriculum where they're being guided on, this is what you can expect, you need to approach this suspiciously, et cetera. So,
Okay.
We have another opinion over here, and
But
then
one
another
last
question over there.
thing. I guess education should not be just like chasing the shining object.
no,
Sure,
I
right?
agree.
So
You would, and no one can accuse higher education of adapting quickly. I don't think anyone's going to come at us.
and
for
we
that.
should believe in the student that they are able to learn the tools that they need to use in their work or career, and
Yeah.
it's
I'd
not
actually like to
all-
hear from a student or two if they, but go ahead, Joel, whoever had the thought first. But students, think about this for a second, because I'm coming to you.
Yeah, so
We're
I kind of
recent
feel
students.
like, well, I'm a sophomore computer science student at JMU, and I feel like somebody who's used, like, I haven't delved super deep into any sort of like generative AI for any code, but I feel like it doesn't matter how powerful you can make the AI, because you still have to know, like everybody else was saying, like the fundamentals, because you need to know what to ask it. Like, if you don't know what you're looking for other than just like, you know, the surface level, I feel like you're probably going to end up with something that's different than what you want, you know, until AI becomes really, really good at understanding what we want, which, you know, like that's a whole other thing.
Although I'm still shocked at how good it is. Like, it just
yeah.
leap bounds over what my expectations were. So,
Yeah, but I feel like it's still important for people to know like what they want and know like the fundamentals so that they can figure out, you know, what they want and figure out what they need from the AI.
Yeah. it makes me feel better.
I will say, just from having been the programmer and been the management side, one of the first things I ask when I'm interviewing somebody is, okay, great, you know 36 languages. When you're up against a problem, do you know where to go for help? And that, you know, be it Reddit, Stack Exchange, any of those. But yes, you still need to know the core of the language, because I mean, I spent 30 years in Florida. What do you do when Comcast goes down?
So I forget the details of the names involved, but I was reading some research recently that showed when somebody posed a bunch of questions to generative AI engines that which required it to give answers that involved the names of packages to download and depend on, that a substantial portion of the answers were hallucinated, that a substantial fraction, something like as much as like 20% of the names generated did not actually exist. And this researcher also found that these hallucinated answers were consistent enough that you could then go and create a project with that name and therefore trick unsuspecting users that
Yeah.
generated AI in order to download these
Yeah,
packages.
and then
So-
put some vulnerabilities in that code, and then, yeah.
Absolutely. So I think not only so the idea of trying to run code that a Gen AI gave you that you haven't actually looked through with in great detail, or even something that you don't even have the ability to understand. That's
It's
scares
scary,
me.
yeah.
I feel like no, we have to know the stuff really well.
And
or
some of this
otherwise-
comes back to like the distinction that I was saying where in the beginning in AI, we were really like, we have to understand this. And we've moved far enough away from that we don't really have the understanding. We have just models that perform really well without actually understanding what they're doing or whatever's happening in that neural net that, like, at least with the probabilities, I could see where it was coming from, but now I feel very confused about what the neural net thinks it's doing. So,
I have to agree with you on that one. With my demo, I gave it the library that I needed to use because I've delved into the research of it, checked its authenticity, have looked at, comments and issues with it and all of the above because I've been in the situation where I've asked for, certain drivers and things like that, and it completely hallucinates them and points me astray for that. So I agree with that 100%.
So I know we are actually up against break at this point. We've done our hour. I'll leave it to someone with more clout than me to decide if we want to keep going a little bit or end. Do we have any actual people in charge?
I mean, does anybody have a question that's going to change our lives today? We need to hear that. We can all give it a couple extra
Because
minutes.
clearly the session did already, so.
We got a big one.
No pressure.
All right. 2-minute time cap.
So when Google first got big, I was in 6th grade. I had no idea what was going on. That was the last big paradigm shift before AI, I feel. First, it was manuals and classes, and then it became searching it on Google and finding answers on Google and copying and pasting from Google.
Mm-hmm.
You might have more nuance and more hallucination in AI now, but were
I don't know,
people
Google hallucinates.
were people as afraid of Google then as we are of AI now?
Not to my recollection. There's certainly some angst about Stack Overflow and Google, but really we can trace that to the source. We can also search that. We can figure out where you got that code, and we can go, look. Now that it's being generated and we can't, and it'll generate different answers every time, and it makes it much harder from an academic honesty perspective, and we have ways around it, but they're like blunt instruments, like, okay, you're gonna do all the labs for your own good, they're gonna be, this much of your grade, and the test is now gonna have to be this much of your grade, because that's all we know that you did. It's really, that's not how we want to do things, because the labs to us are way more important than your exam performance, but we're kind of at a loss as to how to make sure the people, earning grades are actually achieving the material. And it's gross. I don't like it. But it's kind of where we are.
Put it around.
I don't know if I want, oh man.
All right. So to the question of to what extent should we teach generative AI in schools? It's what I find interesting. So I have a JavaScript background for a long time, and so I've seen all the churn that everyone knows in the JavaScript community. And there's been a ton of new technology that comes about all the time. And most of that technology comes about just because people like don't like the way something's done. Don't like the way something's done. And so they want to do it their own way. But in that process, there's a ton of innovation. So we have seen performance gains, fundamental shifts in how people build UI.
Yeah.
Apparently I'm moving my hand too much. And all sorts of great stuff. So what I find really interesting is if we get past all the hallucinations and stuff like that, and this technology gets better, because a couple years ago it didn't even exist, so that we're already here is pretty extraordinary. And it starts being a tool that you could just say, hey, I don't know any programming language. I just sit down and I ask questions, and I know that this needs to be in JavaScript, so I tell it to do it in JavaScript, and it produces that JavaScript for me. I don't think that's too crazy, based on what I've seen so far. If that happens, who is going to be the one innovating all of these things that happen because you didn't like the programming language or the tool that you were using before?
I think I know who filled out this survey.
So basically, if we don't, if I think there's like the practitioner side of things, that if we taught students how to use generative AI, maybe that really equips them super well for a job and things like that, and that's great. But like, is the technology going to stall because no one's really digging in and understanding the nuts and bolts behind the scenes that are like actually powering and doing things that we need to do? And is our schools, higher education, the place that we should be training those people that really need to do it?
Right, and I spotted that kind of similar question in the survey results, and I did think that was really interesting, so I kind of pulled that out as, if we have time, I definitely want to mention this, but that is a really interesting thought, right? Are we going to kind of become so reliant on this that innovation will stall? Or is AI just going to be innovating for us? Oh my gosh, right? So yeah, that's a good place to end on that, like, oh crap kind of perspective.
Put it your hands
But yeah, I think that's
together.
valid and an interesting thing.